One injection can lower cholesterol levels for life. Promising research results of the new method. Using gene editing techniques, scientists have developed a therapy that turns off the gene that regulates the so-called bad cholesterol. In preliminary studies involving 10 people, this therapy effectively reduced LDL cholesterol levels by more than half. The effect lasted for 6 months, but scientists expect it to be permanent. The treatment has shown extremely promising results, but there are questions about the safety of the therapy. The study was conducted in New Zealand and the UK and involved people suffering from an inherited disease that causes very high LDL cholesterol levels and therefore a very high risk of heart disease. Scientists from Verve Therapeutics from Boston are behind the development of the therapy, and they hope that their method will allow you to get rid of the problem of high levels of bad cholesterol for life with just one injection. The study results were presented at the American Heart Association meeting in Philadelphia on November 12. The tested therapy could potentially be a revolution. Perhaps it will help reduce the risk of death from heart attack and stroke by lowering the level of bad cholesterol. Heart attacks and strokes are responsible for approximately 15 million deaths each year. Verve Therapeutics researchers have presented evidence that a technique for precisely rewriting the genetic code applied directly to the body can effectively lower LDL cholesterol levels, perhaps for life. The company reported that a single injection of Verve 101 reduced the amount of LDL cholesterol in the blood by up to 55%. In study participants, Verve 101 permanently deactivates in the liver the gene encoding the Fk2K0 protein, which breaks down enzymes that remove cholesterol from the blood. Turning off this gene increases the amount of these enzymes, thereby controlling the level of low-density lipoprotein, LDL, low-density lipoprotein, i.e. bad cholesterol. LDL cholesterol narrows arteries, blocking blood flow to the heart and brain and causing heart attacks and strokes. This is the first time that editing a single DNA base pair using gene editing technology has been shown to have a clinical effect in humans, said Ritu Thaman, a cardiologist at the University of Pittsburgh in Pennsylvania, who was not involved in the study. From a clinical point of view, this could potentially open up a new way of treating coronary artery disease, he added, pointing out that this method could involve a one-time treatment, instead of the daily tablet intake that is used in currently recommended therapies. In the studies, scientists administered different doses of Verve 101. The patients were aged 29 to 69 years. 3 patients received a dose high enough to cause high reductions in LDL concentrations. In 2 patients, a 39% reduction in LDL levels was observed. And 48%. One patient who received the highest dose saw a 55% reduction in LDL. This decrease is large compared to the results of conventional treatment. Statins cannot achieve such results. The effect lasted until the results were presented in Philadelphia, and the injection took place half a year earlier. In a preclinical study in monkeys, after administration of a single dose of the drug, the reduction in LDL cholesterol was maintained for 2.5 years. It's still early, but this therapy could open the door to a completely new way of treating heart disease, said Sek Kathiazan, director of Verve Therapeutics. We are very excited. This is the first ever evidence that it is actually possible to transcribe a single letter of DNA in the human liver and achieve a clinical effect. So we are delighted. The goal of treatment is to protect against heart attacks and strokes. If LDL cholesterol levels in the blood are very low throughout life, it is difficult to have a heart attack, Kathiazan admitted. The researchers used a genome editing technology called base editing. This is the successor to the famous CRISPR-Cas9 method. It is more precise than its predecessor and therefore probably safer. This study is the first to use base editing techniques in vivo on humans. Base editing uses the same mechanisms as CRISPR-Cas9 to make very precise changes to the gene without breaking double DNA strands. It modifies CRISPR enzymes to replace one DNA letter with another without cutting the DNA. The technique was developed by a team led by biologist David Liu of Harvard University in 2018. Last year, during the first clinical test of this method, scientists put a teenager's leukemia into remission. But then the editing of the genetic material took place outside the body. Scientists took the material, edited it, and then injected it into the patient. In the new research, the editing took place inside the body. Verve-101 consists of two RNA molecules, a messenger RNA molecule that edits adenine bases in DNA and a molecule called guide RNA, i.e. a fragment of RNA that acts as a guide that recognizes PCSK9. It's all packaged in a lipid nanoparticle. After injection, liver cells take up these nanoparticles, which, after entering the cells, enter their nuclei. Then, a single letter change is introduced in the PCSK9 gene sequence. The adenine base is changed to a guanine base. This deactivates the gene and prevents liver cells from producing the PCSK9 protein. For now, however, safety questions remain. The treatment has some side effects. Participants experienced short-term flu-like symptoms, including fever, headaches and body aches, as well as a transient increase in liver enzymes that return to normal within a few days. But these side effects are a bit of a hassle. 2 out of 10 people participating in the study developed serious health problems. One of the study participants who received a high dose of the preparation had a heart attack the day after administration. Verve Therapeutics said in a statement that the heart attack may have been related to the treatment, but could also result from the underlying disease. This participant did not inform the researchers about chest pain that occurred before administration of the preparation. The second of these people unfortunately died. Death occurred 5 weeks after the injection as a result of a heart attack. An independent regulator concluded that the patient's advanced heart disease may have contributed to the heart attack. At this stage, therapies using various gene editing methods are risky. We don't know much about genome modification. Editing can cause unintended genetic changes that can cause health problems even years later. Although in studies in monkeys and mice, scientists found no abnormal editing or evidence that changes to the PCSK9 gene become heritable. The research will continue next year in the United States.